Our oceans are facing a silent invasion. Plastic waste, from bottles to bags, is choking the marine environment. It entangles marine animals, causing injury and death. Sea turtles mistake plastic bags for jellyfish, a deadly snack. Seabirds get entangled in discarded fishing nets, unable to escape. The problem goes beyond what we can see. Microplastics, tiny particles less than 5 millimeters in size, are ingested by marine life. These microplastics accumulate up the food chain, eventually reaching our plates. The consequences for human health are still being investigated, but they are a cause for serious concern. Plastic pollution is a global crisis, demanding urgent action. We must reduce our reliance on single-use plastics and find sustainable alternatives. The natural world, however, may offer a solution. Algae. These humble organisms hold the potential to help us turn the tide against plastic pollution. Algae, often overlooked, are powerhouses of the natural world. They are photosynthetic organisms, converting sunlight into energy and releasing oxygen. But their talents don't stop there. Certain types of algae have shown a remarkable ability to biodegrade plastic and even produce bioplastics. Biodegradation is nature's way of breaking down materials. Some algae species produce enzymes that can break down the complex chemical bonds in plastics. This process turns plastic into simpler, less harmful substances. While traditional plastic can take hundreds of years to decompose, algae offer a faster, more natural solution. Algae can also be used to create bioplastics, a sustainable alternative to conventional plastics. These bioplastics are derived from biological sources like algae and can decompose naturally. Unlike traditional plastics, they don't persist in the environment for centuries, posing a threat to wildlife and ecosystems. The secret to algae's plastic-fighting abilities lies in their enzymes. Enzymes are biological catalysts that speed up chemical reactions. Certain algae species produce enzymes specifically designed to break down the long chains of molecules that make up plastic. Think of these enzymes as tiny scissors, snipping away at the plastic molecules. They break down the plastic into smaller, simpler components. These components can then be consumed by microorganisms, effectively digesting the plastic and returning it to the natural carbon cycle. This biodegradation process is much faster than the natural decomposition of plastic. While it can still take weeks or months, it's a significant improvement over the hundreds of years required for conventional plastic to break down. Section 4. Microalgae. The powerhouses of biodegradation. Among the various types of algae, microalgae are particularly promising for combating plastic pollution. These microscopic organisms are incredibly efficient at photosynthesis, absorbing carbon dioxide and sunlight to produce energy. This ability makes them highly effective at capturing and converting carbon from the atmosphere. Microalgae reproduce rapidly, doubling their biomass in a short period. This rapid growth makes them a sustainable and scalable solution for biodegradation. They can be cultivated in large quantities, providing a consistent supply of plastic-degrading enzymes. Furthermore, microalgae can be grown in various environments, including wastewater treatment plants and industrial facilities. This adaptability makes them a versatile tool for tackling plastic pollution in different settings. They can be deployed in areas heavily affected by plastic waste, helping to clean up the environment. Section 5. From ocean menace to green treasure. Algae bioplastics. Beyond biodegradation, algae hold another key to solving the plastic crisis: bioplastics. Certain types of algae produce substances that can be used to create bio-based, biodegradable plastics. These algae bioplastics offer a sustainable alternative to conventional petroleum-based plastics. The process involves extracting specific compounds from algae, such as starch and cellulose. These compounds are then processed and molded into various forms, just like traditional plastics. However, unlike their conventional counterparts, algae bioplastics decompose naturally in the environment. This biodegradability means that algae bioplastics won't accumulate in landfills or pollute our oceans. They break down into harmless substances, returning to the natural cycle. Using algae to create bioplastics offers a closed-loop solution, reducing our reliance on fossil fuels and minimizing waste. Section 6. A wave of hope. The future of algae in plastic pollution control. Research into algae's potential for combating plastic pollution is ongoing and promising. Scientists are working to identify the most efficient algae species for biodegradation and bioplastic production. They are also developing innovative techniques to optimize the process and make it commercially viable. Challenges remain, however. Scaling up algae cultivation to meet global demand requires significant investment and infrastructure. The efficiency of biodegradation can vary depending on environmental factors, and more research is needed to ensure its effectiveness in different settings. Despite these challenges, algae represent a beacon of hope in the fight against plastic pollution. Their ability to biodegrade plastic and create sustainable alternatives offers a potential solution to this global crisis. As we continue to explore and harness the power of these tiny organisms, we move closer to a cleaner, healthier planet for all.